Welcome back, everyone. Ready to dive into some more fascinating research.
Always.
Today, we're venturing into the world of liquid chromatography.
Ah, yes, those powerful but often mysterious columns.
Precisely. And we've got a paper that literally sheds light on what's happening inside them.
Oh, intriguing. I'm all ears.
So the paper we'll be exploring is titled Visualization of Bed Compression in an Axial Compression Liquid Chromatography Column.
Quite a mouthful.
It is. It was published back in 2002 in the Journal of Chromatography A.
2002. That's quite a while ago.
It is, but trust me, this research was ahead of its time. It's by R. Andrew Shalliker, Victor Wong B., Scott Broyles, and Georges Guiochon.
Those are some serious chromatography giants.
Absolutely. And their work here revolutionized how we think about packing in these columns.
Packing. You mean how the material inside the column is arranged?
Exactly. For years, scientists knew that getting a perfectly uniform packing was nearly impossible.
Right, because that affects how well the separation works.
Precisely. Uneven packing leads to less efficient separations.
But before this paper, it was all kind of theoretical. They couldn't actually see what was going on inside.
And that's where this research comes in. They found a way to actually visualize the packing.
Wow. How did they manage that?
Well, it involves some very clever manipulation of refractive indices.
Refractive indices. Now we're getting technical.
Essentially, they matched the refractive indices of the mobile phase and the stationary phase.
So the liquid flowing through and the material packed inside had the same refractive index?
Yes, making the column itself transparent.
Clever, so they could see right through it.
But there's more. They strategically embedded layers of alumina
Alumina. Why alumina?
because it has a different refractive index than the rest of the column.
Uh-huh. So those alumina layers would stand out visually.
Exactly. They acted like markers, allowing them to track how the packing material compressed under pressure.
That's brilliant, like putting little signposts inside the column.
Precisely. And by observing these markers, they made some groundbreaking discoveries. Well, first, they confirmed that packing density isn't uniform.
Okay, that makes sense.
Yeah.
It's hard to pack things perfectly.
But they went further, characterizing two types of heterogeneity.
Heterogeneity, meaning variation in packing density.
Exactly. They observed radial heterogeneity and axial heterogeneity.
Okay, break those down for me.
Radial heterogeneity refers to the variation in density from the center of the column towards the wall.
So like a bullseye pattern denser near the edge?
Yes, they actually confirmed the existence of something called the wall effect, where the packing is denser near the column wall.
Interesting. And what about axial heterogeneity?
That describes the variation in density along the length of the column.
So from top to bottom.
Precisely. They found that the packing becomes denser towards the bottom of the column.
I wonder why that is.
Well, it likely has to do with the way the compression force is applied during column packing.
Makes sense. Gravity and all that.
Exactly. But this density variation has significant implications for how molecules separate within the column.
Oh, I bet. Uneven flow and all that jazz.
Exactly. We'll dive deeper into those implications, but first there's another key finding we need to discuss.
Get me with it.
They discovered that the bed compression isn't perfectly symmetrical.
As in, it compresses unevenly.
Precisely. And that has a lot to do with how the compression piston makes contact with the packing material.
So even tiny imperfections in the setup can affect the entire column.
Precisely. It really highlights the importance of precision in column assembly.
It's fascinating stuff. Who knew there was so much complexity hiding inside these columns?
Right. And we're just getting started. We'll unpack these findings further and explore their impact on separation efficiency in our next segment.
Can't wait. This is making me look at my columns in a whole new light.
Me too. It's amazing what we can learn when we have the tools to see the unseen.
Absolutely. Knowledge is power and seeing is believing. So they could actually see the compression happening in real time.
Exactly. And they didn't stop there. They also used a dye to visualize the flow patterns within the column.
Oh, wow. So they could see how the liquid moved through the packed bed.
Precisely. They injected the dye near the column wall.
What did they see?
Well, it beautifully illustrated that uneven flow we were talking about.
Caused by those density variations.
You got it. The dye closer to the center of the column.
Where the packing was less dense?
Yes. It moved much faster than the dye near the wall.
Uh-huh. Visual confirmation of that wall effect.
Exactly. It's like watching band broadening happen right before your eyes.
So those wider peaks we sometimes see in our results, it's because of this uneven flow.
Precisely. This dye visualization really drives home the point.
Makes you realize how crucial understanding these packing dynamics is.
Absolutely. It's not just about picking the right column or the right mobile phase.
It's about appreciating the whole system. those intricate interactions happening inside.
Exactly. And this paper gave us a powerful tool to peek into that hidden world.
And it's fascinating how even something like friction plays a dual role here.
Oh, right. The paper mentions that.
Yeah, friction is the enemy when it comes to uniform packing.
Because it creates those density variations.
But at the same time, it's also what holds the column together.
A delicate balancing act.
It is. Too little friction and the column could collapse too much and you get uneven packing.
So it's all about finding that sweet spot.
Which is easier said than done, I'm sure.
Oh, definitely.
Yeah.
But this understanding of friction's role has led to some cool innovations.
Like what?
Well, researchers are now developing new packing materials and techniques.
To minimize those undesirable effects of friction.
Exactly. They're aiming for more robust columns that can withstand higher pressures.
Without sacrificing packing uniformity.
Precisely. It's a constant push for improvement.
Driven by the desire for better and more efficient separations.
Absolutely. Now, going back to that asymmetrical compression we touched on earlier.
Ah, yes, the unevenness.
What implications does that have for chromatography?
Well, it really underscores the importance of precision in column manufacturing.
Because even slight variations in how the column is assembled
Can lead to significant differences in packing.
and ultimately impact performance.
Exactly. It's a chain reaction starting from the very beginning.
This study has really opened our eyes to those subtle but crucial factors.
It's all connected, isn't it? The materials, the equipment, the operator's technique.
It's a holistic system,
Right.
and understanding those connections is key to achieving consistent and reliable results.
Well said. And this paper has provided us with invaluable insights into those very connections.
It's remarkable how a single research paper published over 2 decades ago.
Can still have such a profound impact on the field.
It's a testament to the enduring power of fundamental research.
And the brilliance of those who dare to see beyond the surface.
By illuminating the hidden workings of these columns,
Shalliker, Wong, Broyles, and Guiochon paved the way for countless advancements in separation science.
their legacy lives on in every sharp peak we achieve in our labs.
Every clean separation a testament to their groundbreaking work.
Indeed. This deep dive has been an eye-opening journey into the heart of liquid chromatography.
We've uncovered the mysteries of bed compression.
Explored the crucial role of visualization in scientific discovery.
And gained a newfound appreciation for the complexity and elegance of these powerful tools.
But our journey isn't over yet. We'll be back with our final segment to wrap up this deep dive and leave you with some thought-provoking questions to ponder.
So stay tuned, we'll be right back after a short break. It's like opening a door to a whole new set of questions.
Right, and even within axial compression columns.
There are so many factors at play.
Absolutely. The packing material, the particle size,
The compression.
all contributing to that final packing structure,
It's a complex puzzle, but understanding these pieces.
is key to optimizing our separations.
Exactly. And that's what makes this research so valuable.
Gives us a framework to think about these challenges.
And to develop better solutions.
So, while we might not have all the answers yet,
This study definitely pointed us in the right direction.
it's like they shone a light on a previously hidden world,
And that's what science is all about, isn't it?
unveiling the unseen,
Pushing the boundaries of knowledge.
and constantly striving for a deeper understanding.
Well said. I think we've covered a lot of ground today.
We have this deep dive into the work of Shalliker, Wong, Broyles, and Guiochon.
Has really highlighted the complexity and the beauty of liquid chromatography.
It's amazing how much we've learned about those seemingly simple columns.
Right. From bed compression to flow dynamics.
And the crucial role of visualization in scientific discovery.
It's all connected, and it all contributes to achieving those perfect separations.
So as we wrap up this deep dive, we encourage you to keep exploring.
Keep questioning and keep pushing the boundaries of knowledge.
Because in the world of science, there's always more to discover.
And who knows what groundbreaking insights await us just around the corner.
Thank you for joining us on this exploration of liquid chromatography.
Until next time, happy separating.